Hey there, year 11. So now we're actually going to apply, in example 21, we're going to apply our understanding of inverse functions. Here we say that find the inverse function of the function f of x equals 2x minus 3 and sketch the graph of both, right? So A, if the function is equal to 2x minus 3, I normally like to use x and y, so I'm going to say let f of x equal to y. So now I have y is equal to 2x minus 3. And to do the inverse, okay, so to find f inverse, we know that xy transformation becomes yx. Okay, so I'm essentially saying x equals y and y equals x. So this now changes the equation to now x is equal to 2 times y minus 3. So when I rearrange it, that's what I'm solving for the inverse. So I'm rearranging it, x plus 3 equals to 2y. Y is then equal to x plus 3 all over 2. Okay, or you can say the inverse function must then be 1/2 of x plus 3 over 2. Okay, so I've just split the fraction up. That's all I did. Cool. So that's my inverse function. And now they want me to sketch that graph, both of which on the x-axis or on the same graph axis. So when I do it, we can just quickly do a quick sketch. 2x minus 3, put in the coordinates of the intersection. So we've intercepts. We've got y-intercept at -0, -3, so 0, -3. And then we've got x-intercept at 3 on 2. Again, I'm doing all this very quickly in my mind because I'm assuming that sketching straight lines is fairly straightforward at this point. So that's my equation, okay, for f of x. So this is f of x. And then for my inverse function, it's 1/2 x plus 3 on 2. And I know that the intercept here would now become, the y-intercept is clearly 3 on 2. And really, you don't have to think too much. Since you found the x-intercept and y-intercept of the function, you can also find the intercept and y-intercept of the inverse. Because remember, the x-intercept will now become the y-intercept. So it'll be 3 over 2, 0, 3 on 2. Okay, and the x-intercept, instead of it being 0, -3, it now becomes -3, 0. Okay, so I know that the graph is going to look more like this. Okay. So clearly there's going to be a intersection at some point. I'm just trying to get back the... it's not perfect because I should have drawn it a bit longer. That kind of works, yeah? Oh. Ish. And then the blue graph. Ooh. Oh no, let's do it in blue. There we go. So something like that, but we know that there is a mirrored image right in the center, which must be something like this. This is where it's a bit hard to do, but there must be a mirrored line here. That's where they're reflecting off from each other, and that's your y equals x line, and that's reflection. Okay, so that's essentially what my inverse function looks like. I'm just going to write here f inverse of x, and they say find the inverse. So they do the same thing again, 2x minus 3, but they've got 2 to 6, and then state the domain and range of g. Okay, so I'm going to do part B. I just find this tedious because but they didn't ask us to sketch, so that's okay. So find the inverse of g. So if g of x is equal to 2x minus 3, which is the same thing, we know that g inverse is going to end up being 1/2 x plus 3 on 2, okay, because we already done part A. But the difference is the domain is 2 to 6. So they want us to find the domain and range of the function. So start off, you need to roughly sketch what 2x minus 3 looks like. Okay, so we already knew that y-intercept is at 0, -3, and the x-intercept is at 3 on 2, right? So roughly, this is what it should look like. I'm going to draw a line across them. So that's what my graph should look like. But remember, it has a domain from 2 to 6. So that means I can only sketch from 2, which is around here, because 3 on 2 is 1.5. So 2 must be from this point to 6 is, say, up here. And then that means part of my graph, I'm only sketching from here to wherever 6 is. Okay, so 6 is up here. So really, I don't need that green graph anymore. There we go. That's my graph. So if we were to figure out the domain and range, well, domain we already have. The range, we need to know what the y value is when x is equal to 2. And we need to know what the y value is when x is equal to 6. Okay, 6, what is the y value? And then 2, at 2, what is the y value? So now I need to find out the endpoints. Here we go, we work it out when x is equal to 2, then g of 2, which is the y value, is 2 times 2 minus 3, gives me 1. Okay, so that tells me that this must be 1. And then when x equals to 6, g of 6, which is 2 times 6 minus 3, is 12 minus 3, which is 9. So that tells me up here, that's 9. So clearly, what's my range? My range is from here to here, which is 1 to 9. So if I were to answer the question, right, domain and range. So here we go, I'm going to write domain. I'm going to write range for my function and then my inverse function. The domain is clearly what they gave us, which is from 2 to 6 inclusive. And the range we found out was from 1 to 9. Now we know based on the property of inverse functions, the range of the inverse will become 2, 6 because that's the domain of the function is the range of the inverse, right? And then similarly, this would then be 1, 9. So just to remind you, this becomes this. And then we know that 1, 9 becomes this. Okay, so there we go. We answered the question, what is state the domain and range, but you had to sketch the graph to help you visualize, to analyze it properly. So that's essentially how you do example 21. It's about sketching, it's about knowing the properties of the inverse function, and that helps you to answer the questions there. Okay.